Lebron. We have Today what we are about to start is another chapter known as relations. In maths, there are certain chapters that are always interconnected. For example, if I talk about there's another chapter probability. So if I want to teach you probability of class 11, I would need to complete set theory first, which you have done. I can't do probability before that. Similarly, the chapter that I'll be starting today, like logarithm, we don't do logarithm without doing indices. It's not possible because you need the same simplification and algebraic things, right? Similarly, when we are doing like we completed sets. So after sets, there are three chapters that are very interconnected. Start with sets because sets is like ABCD. It teaches us how to identify the collections, which collections can be defined as sets. So, what was that? Well defined collections. Once we know that, we then form different sets like natural numbers, real numbers, rational numbers, then varieties, singleton set, null set, finite set, infinite sets. Then we talk about how to write them, whether it's a roster method or a set builder method. Then what we do is we learn about subsets. In that, we learn about proper subset. Then comes the major part of it, that is powers operations. That is union, intersections, and everything. So when we ended up, that was operations. In case of union, what we used to do is to write everything all together, combined format. When we used to do intersection, that was common. And then we also learned about difference, A minus B or B minus A. What I'm about to start is the chapter relations. As I said, sets, relation, and function. You have to go in the same order. I can't change the order also. You learn letters, then you learn to form words, then you learn sentences, and then paragraphs and comprehensions, right? That is the order that is here. So we first define sets, then we operate them and go to relations. Then again we do something and we go to functions. Function is a very broader perspective that opens up hugely. So that is from where math takes a very different form altogether, right? So relation is one of the most easiest topic that you will see in your syllabus. It's a very small topic also. Maybe we can complete it one lecture also. So before moving on to relations, we have a transitional phase between sets and relations. So that is Cartesian product. We are going to multiply two sets. When we are multiplying, we have already done plus, we have done minus, plus is union. Okay. So we have done additions, we have done subtraction. What we are about to learn is multiplication. Right? Before learning multiplication, without learning multiplication, we can't move on to your relation, and without relation, we can't move on to the chapter function. So, don't write. When I say multiplication of two sets, A multiplied by B, this is Cartesian product of A and B. Now, it's very important, like when we are multiplying numbers, 2 into 3 or 3 into 2, it doesn't matter, right? It gives you 6. What will it be the same process here? You will find out. So right now, when I said I want to find the product of A and B, from my mouth, the first set that came out was A. So A is my first set, B is my second set. So I'm multiplying A and B. What does multiplication or Cartesian product does is, it's going to form pairs. So in for us, pairs will be coordinates, right? What do we do? 1 comma 2, it's a pair. 1 is related to 2. Similarly, here we are going to form pairs. Now, when I'm forming the pairs, what we need to be very sure and certain that all my x coordinates has to be from my first set. What is my first set right now? A. And all my y coordinates have to come from the second set B. That is, has to be there. Now, what will A into B tell you is, you need to form every single possible pair that you can. So I'll take each and every element of the first set A and form its pair with all the elements of the second set. Then I'll move on to the next element and again form the pair with everyone. For example, here, this is arrow diagram. This is A and this is B. Within these ovals, which we write the element that a set has. The size doesn't matter here. So 1, 2, 3, suppose A, B. So my set A has 3 elements, 1, 2, 3. My set B has 2 elements A and B. Cardinality of A is What is cardinality? What is cardinality of a set?
Number of elements.
Number of elements in a set. And cardinality of B will be
2.
Now, what we'll do is all the three elements of my first set A will pair up with both the elements of the set B. So I start from the first set. I take one. One will be paired with A. One will also be paired with B. So when I'm going to write it, I'll write one is paired with A. This is one pair. This is one coordinate. Then one will be paired with B. Then comes the job of 2. 2 will again be paired with both of them. Right? So it will be 2 comma A, 2 comma B. Then 3 will also be paired with both the elements. So 3A, 3B. Is there anyone else that I can link up? Are there any more pairs that I can form?
No.
No.
No. So that's my A cross B. So first I took one. One will be forming two pairs because there are two elements in my second set. I take another element 2. Again, 2 will be paired up with two elements. I take another element 3. 3 will be paired up with two elements. So each one will be paired up with everyone. 3 times 2, 2 pairs. So it makes a total of 6 pairs. So you can see the number of elements in A cross B is basically 6, which is 3 into 2, product of the two elements. Yes. So if my first set A has 4 elements and my second set B has 3 elements, then A cross B will have
12.
12. If set A has 5 elements, set B has 2 elements, then my A cross B product will have
10 elements.
10 elements.
10
What
elements.
about B cross A?
Same.
2 into 5, 10. Let's see here. Suppose here I want to write, see this was arrow diagram. Huh? This is arrow diagram. We form ovals for each of the set. All the elements are written within the set and the pairs are joined by an arrow. Now I want to write B cross A. Can you all quickly tell me what would be B cross A, please? You need a 10-second pause. What's B cross A?
A comma 1, B comma 1.
So from B we have A and B, and from A we have 1, 2, 3. So my B cross A will be A1, A2, A3, A comma 1, A comma 2, A comma 3. Then for B, again I'll have the three pairs B1, B2, B3. So B1, B2, B3. Again 6 pairs. So both A cross B and B cross A will have 6 pairs. So that means the cardinality of A cross B and B cross A are same. The cardinality of A cross B and B cross A are same. Do you all agree? Yes. What are those sets known as whose cardinalities are same? Two sets with same cardinality are known as? So the question was equivalent. The answer is equivalent. If two sets have the same cardinality, the number of elements present in the two sets are same. Those two sets are known as equivalent sets. So A cross B here had 3 into 2, 6 elements. B cross A also had 6 elements. Since their cardinalities are same, number of elements in A cross B and number of elements in B cross A are same. So they are known as equivalent sets. Clear? Since number of elements in A cross B is same as number of elements in B cross A, therefore they are equivalent. This was the symbol, right? So if I want to write, please note down definition. What is A cross B? A cross B or product of A and B. It is Cartesian product of A and B. It is the set of all pairs from A to B, or X comma Y, set of all the pairs such that the first element X has to be from the first set and the second element Y has to be from the second set. So if I say that an element 3 comma 5 belongs to P cross Q, an element pair 3 comma 5 belongs to P cross Q, then what does it tell you in return? 3 comma 5 belongs to P cross Q. So from this line, what information do you receive? The X coordinate, that is 3, will be from the first set P, and the Y coordinate 5 will be from the second set Q. Understood? That means, example, if I say 5 comma 7 belongs to A cross B, what does this give us? That 5 will belong to the set A and 7 is also present in set B. Both of them will be happening. Clear? All the X coordinates come from the first set. All the Y coordinates come from the second set. In general, note first, number of elements in A cross B is same as number of elements in A, number of elements in B, product of their cardinalities. So if A has 5 and B has 6 elements, the product will have 30 elements. Same goes with B cross A. Therefore, A cross B and B cross A are equivalent. Can you tell me whether they would be equal? Will they be equal? Because A cross B, if it has 5, 7, that means 100% B cross A will have. If 5 comma 7 is present in A into B, then what would be present in B into A?
7 comma 5.
7
7
comma
comma 5, all of you agree. So is 5, 7 and 7, 5 same?
No, ma'am.
No, ma'am.
Because 5 comma 7 will be somewhere around here. But if I want to plot 7, 5, it will be somewhere around here. The coordinates are different. So since the X coordinate and Y coordinate swaps, so A cross B and B cross A are not equal. The two sets are not equal. They can only be equal if the sets itself are equal. Exception. A cross B will be same as B cross A if and only if A is same as B, otherwise not. If both the sets are same, only then the product will be same, otherwise no. Am I clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Question. Suppose I have A 1, 2, 3 and I have B 2, 3, 4. How many elements will be there in A cross B?
9.
9. And same will
9.
be in B cross A also. So please
Yes.
can you find out A cross B and B cross A? Find out A cross B and B cross A. Find out A cross B and B cross A.
I'm done now. I'm done.
A cross B. Answer?
9.
9.
9 elements. No, but We have to write them. 1 2 1 3 1 4 2 2 2 3 2 4 3 2 3 3 3 4. What about B cross A then? 2 1 2 2 2 3 3 1 3 2 3 3 4 1 4 2 4 3. Everybody, all of your answers match?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay. Carrying the same question, can you tell me what is A intersection B? What is intersection?
Common elements.
Common
Common.
element. What are the elements common?
2 and 3.
2 and 3.
2 and 3 are common in both the sets. So
Sir.
the number of elements that are common in A and B are 2. Yes. So if I would not have even done A cross B and B cross A without looking at that, I'm sure that since A and B has 2 and 3 common, that means here also I have 2, 3. Here also I have 2, 3. Without looking at the product, I am sure and certain that my products will have 4 common elements. 2, comma 2, 2, comma 3, 3, comma 2, 3, comma 3. See, there are no more elements common. Why? Because only those elements, those pairs are common which are obtained from these 2, 3. Right? So, A cross B intersection B cross A will be 2, 2, 2, 3, 3, 2, 3, 3. So, if A and B would have had 2, 3, 4 common, 3 elements common, then the product will have if A and B has 3 elements common, what 2, 3, 4, 2, 3, 4, then the product will have how many common elements?
9.
9.
9.
2, 3, 4, 2, 3, 4 will pair with among themselves. So 3 into 3, 9. 2, 2, 2, 3, 2, 4, 3, 2, 3, 3, 3, 4, 4, 2, 4, 3, 4, 4. So I'll have 9 elements as common. Is that understood? So note, if number of elements that are common in A and B is P, then number of elements that are common in these products will be square of that. If there are 4 elements common, then the product will have 4 into 4, 16 common elements. If A and B have only one common element, then the product will also have 1 into 1, one common pair. Yes?
Yes, ma'am.
Yes, ma'am.
Any doubt till here?
No, ma'am.
No, ma'am.
Second,
Ma'am.
if there are 2 common pairs, A, B, there are 2 pairs which are same. So if I'm saying that there are 2 graphs that are same, 2 locations same, 2 plotting same, that can only happen if the coordinates are same. When will the coordinates be same? If both the x coordinate, the axis and ordinate are same, both x coordinate and y coordinate have to be same. Because if I say 1, 3 and 1, 4, they won't give you the same point. If I say you suppose 2, 3 and 4, 3, it won't give you the same location. What will give me the same location? 1, 2, 1, 2, 3, 2, 3. Right? So if AB and CD are equal, it means both the x coordinates as well as the y coordinates are equal to each other. Both the x coordinates as well as the y coordinates are equal to one another. Yes? So from here, the questions that can come, suppose I have 2a plus b and I have b. This is equal to 5, comma 1. So from here, what can I say?
2a plus b is equal to 5 and b is equal to 1.
So b is 1 already. We'll put this value here. 2a plus 1, 5. 2a, 4. A would be 2. A would be 2. Clear? So the complexity may change. Some equations may be easier, some may be harder, but the process is same. Yes?
ma'am.
Yes, ma'am.
Now, if I say, supposingly question, the number of elements in A cross B, 6. Number of elements in A is 2. I'll continue the question. First, can you tell me how many elements will be present in B?
3.
Obviously 3. Because number of elements in A cross B is product. This is 6. This is 2. So if it is MCQ, don't write anything. Just in case the working has to be shown. The number of elements in B will be 3. Done. Now I was saying is some elements of A cross B. So technically A cross B should have how many pairs? 6. I'm not going to give you 6 pairs. I'm giving you 3. X1, Y1, Z2. I've given you 3. So if I'm saying that a certain element is present in A cross B, that means the X coordinate is a part of first set. The Y coordinate is a part of the second set. So my first set here is A. So A should have how many elements? My fault. My pair is wrong. My fault. Sorry. Yes. So all my first set A will have all the X coordinates, and we know it for a fact that A should have only 2 elements. Right now, if you can see all the X coordinates together, tell me that A will have A will have
X and Y.
XY, and B will have all the Y coordinates. B will have all the Y coordinates, which is
1, 2, and 3.
1.
1,
2,
2,
3.
3.
So technically A cross B should have had 6 elements, right? They have given us 3. Can you tell me what are the remaining elements? If you directly can't think, and write A cross B first and then match. So A had XY, here we had 1, 2, 3. X1 already written. X2 already written. X3 not written. Right? Then Y1 not written. Y2 left. Y3 is already done. So these are the only 3 elements that are left out. Clear?
Yes, ma'am.
Yes, ma'am.
Everybody clear? Question. If I want to give you A has 1, 0. How many elements does A have? 2. So A square will have,
4.
A cube will have 2 into 2 into 2, 8. So let us find A square. A square means what? A into A. So 1, 0 will pair with 1, 0. Let's try. 1, 1, 1, 0, 0, 1, 0, 0. 1, 1, 1, 0, 0, 1, 0, 0. Now, if I see, when I was writing A square, I got ordered pairs, 2, X coordinate, Y coordinate. If I'm writing A cube, I'll get ordered triplets. There will be 3, each one coming from each of the corresponding sets. So if I say A cube, I can write it as A square into A or A into A square, any which way. So A square multiplied by A. A square has these 4 pairs. And A has pair 1 and 0. So each one of the element of the first set A square will pair with every element from the second set A. So both the pairs 1, 1, 1, 1, 1, 0. Both the pairs 1, 1, sorry, my fault. 1, 0, 1, 1, 0, 0. Then both the pairs 0, 1, 1, 0, 1, 0. Both the pairs 0, 0, 1, 0, 0, 0. Done? 8 plus 2 into 2 into 2, 2 fours are 8. Yes?
Yes, ma'am.
Yes, ma'am.
Here, the x coordinate, the y coordinate, z coordinate, all of them comes from the set A. Right? So now, if I say that a power 4, a square has 16 elements and some elements of a cube are 1, 0, 1, 0, minus 1, 2. Find first a and second find a square. Second find a into b if b has x and y. It's an interesting sum. So first we have been given that a square has 16 elements. So what will I get from here first?
Enough here.
Right?
And we will get enough here.
Number of elements in A is 4.
Yes, ma'am.
Cardinality of A would be 4. Now, if since 1, 0, 1 and 0, minus 1, 2 belongs to A cube. A cube is A into A into A. So x, y, z, all the three coordinates are from the set A, and we know it for a fact that set A has 4 different elements. So from here, can you tell that what will be there in set A?
1, 0, minus 1 and 2.
1, 0, minus 1, 2. All these elements are members of the set A. Clear? This was first. In the second one, I have A. 1, 0, minus 1 and 2. I have set B, x and y. Now, can we find A into B? Can you tell me what will be the cardinality first?
8.
8. So let's write. Please let me know.
1, comma
1x, 1y, 0x, 0y, minus 1x, minus 1y, 2x, 2y. Does it match online?
Yes, ma'am.
No.
Any doubts still there?
No, ma'am.
Now, here what we were doing is in A cross B, if nothing additional is written, then every single pair has to be found. But in some cases, I'll give you a condition. If I have given you an added condition, then you have to keep that into consideration while forming the pair. Right now, when we are taking admission, we don't filter, right? Whoever wants to take admission, no matter how much you've got in class 10, it doesn't matter. You can take the admissions. For example, if I would have been a college or you would have been applying in a college, can we do that? No. There is a certain criteria. If that criteria is met, then yes, you can take the admission. Yes, you will be forming the pair. Otherwise, no. For example, question. Set A has 5, 6, 7 and set B has 4, 5, 8. Find A cross B if A comma B belongs to A cross B implies A is more than B. That means a pair will be present in the product only if A, that is the x coordinate, is larger than the y coordinate. If your elements satisfy this criteria, only then you are allowed to form the pair, otherwise not. Yes? So A cross B, 5. Can I pair 5 with 4?
Yes, ma'am.
Yes.
Yes, because 5 is more than 4. The x coordinate is more than the y coordinate. Can I form 5 pair with 5?
No.
No, ma'am.
No,
No,
ma'am.
because they're equal. It has to be greater. If the question would have been A greater than equal to B, then I could have. Can I form 5 and 8?
No.
No, ma'am.
Let's try with
No,
6.
ma'am.
6, 4,
Yes, ma'am.
Yes, ma'am.
6, 5,
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
6, 8.
No, ma'am.
No,
No,
ma'am.
ma'am. No,
Next,
ma'am.
7. 7, 4,
Yes, ma'am.
Yes,
7,
ma'am.
5,
Yes, ma'am.
7, 8.
No, ma'am.
No, ma'am.
So in A cross B, technically I should have had 3 into 3, 9. But since a condition was written, I could only form this. So right now this was a condition. I could also give you an equation, right? If an equation is written, then only those elements that satisfies that equation we can. For example, A cross B equal x comma y such that x plus 2y equal 10. If A is equal to 1, 2, 3, 4 and B is equal to up to 10, find A cross B. So the pairing will start from here. The x coordinate will come from the first set A. So if I take x equal to 1, the coordinates has to satisfy this equation. So x plus 2y equal to 10, 1 plus 2y equal to 10. So y is 9 by 2. But this y coordinate has to be a member of B and B does not have it, right? So will a pair be formed here using x equal to 1?
No.
No.
Mm.
For x equal to 2, 2 plus 2y equal 10, 2y 8, y is 4. Can I form this pair?
Yes.
Pair would be x comma y, right?
Two,
So 2 comma
Yes, ma'am.
4 will belong to A cross B. X equal to 3 then. So y is 7 by 2. That does not belong to B. No. If they take x equal to 4. I'm sorry. Y would be 6 by 2. 3. It is a member of B. So the pair would be from 4 comma 3. Is there any other pair that we can think of?
No, ma'am.
No. So A cross B will have only two pairs. 2 comma 4 and 4 comma 3. Otherwise, you would have 40 elements. But since a criteria condition was given, so we could only form those pairs that satisfies this criteria. Any problem?
No,
No, ma'am.
ma'am.
Can I remove this?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Question. If A cross B x comma y such that x plus 2y equal to 6 and A comma 5 belong to A cross B. Find small a. What should we do? What should we do?
Ma'am, we have to substitute 5 in the equation and
So
find
A
it.
comma 5 is in A cross B. So A is the x coordinate, 5 is the y coordinate. So I can put in this equation x coordinates and y coordinate because if it is pair, if it is present in the pair, right, A cross B, that means it has definitely satisfied the condition. We just solved the sum. So x plus 2y is equal to 6. Since A comma 5 is a pair that belongs here. So instead of x, I can put A. Instead of y, I can put 5. So the value of A is negative 4. Yes?
Yes, ma'am.
Yes,
Any
ma'am.
doubt?
No, ma'am.
No, ma'am.
All of you clear?
Yes.
Yes, ma'am.
Let's try exercise 5.5 of ML Agarwalla. The first number 1, a plus 1, b minus 2 is same as 3, 1. So from here, a plus 1 is 3, which gives us a equal to 2. B minus 2 equal to 3. So B would be 2, 1. 4x plus 3 comma y is same as 3x. My fault. B minus 2, 1. So B equal to 3. Now yeah, both the y coordinates same. Y is minus 2. Both the x coordinates are same. 4x plus 3 equal 3x plus 5. So x will be 5 minus 3. So done?
Yes, ma'am.
Question number 3. If the ordered pairs A minus 1 and 5 comma B belong to the set is x comma y such that y equal to x minus 3. If A comma minus 1 belongs to the set, so it will 100% satisfy this condition. So instead of y, we can put minus 1. Instead of x, we can put the x coordinate A. So from here, A would be 1. Similarly, 5 comma B also belongs to the set. So B is equal to 2 into 5 minus 3, that is 7. So A is 1, B is 7. Any doubt?
No, ma'am.
Question number 4. A is minus 1, 0, 1 and B is 3 comma 5. So A cross B will be, please respond. Minus 1 comma 3 minus 1 comma 5 0 comma 3 0 comma 5 1 comma 3 1 comma 5. B cross A 3 minus 1 3 0 3 1 5 minus 1 5 0 5 1. Yes,
Yes, ma'am.
B into B, that is basically B square. So 3 5 3 5. So 3 3 3 5 5 3 5 5. Any doubts?
No, ma'am.
No, ma'am. Question number 5. A has 2 elements, 1, 2. B has 2 elements. How many elements will be there in A cross B? 2 into 2, 4 elements. If a set has 4 elements, how many subsets will it have? If the set A
16.
cross B has 4
16.
elements, then how many subsets will it have?
16.
2 to the power 4, that is 16. If they would have asked us how many proper subsets are there,
4m minus 1.
1 less, 15. There are 15
15,
proper
ma'am.
subsets. Very good. Done? 6. X is a member of 2, 3, 5. Y is a member of 2, 4, 6. X has to be smaller than Y. So the pairs that will be formed are 3,6, waiting.
2 comma
2 comma 4, 2
2
comma
comma 4, 2 comma
3
6, 3
comma
comma
4,
4.
3
2, 4,
comma
2,
6, 5
6,
comma 6.
3, 4, 3, 6, 5, 6. Done?
Yes,
Yes,
ma'am.
ma'am.
Set. 7. Equation is x plus y equal to 5. X is minus 1, 2, 3, 4, 5. So if I take X minus 1, then Y would be 6. Yes, I have the option. If I take X to be 2, then Y would be 3.
3.
Yes, I have that option. If I take X to be 3, Y will be 2. No. If I have X4, Y would be 1. I don't have that option. If I take X to be 5, Y would be 0. Eight. X is a factor of Y. X is an element of 2, 3, 4. Y is from 4, 6, 9, 10. X has to be a factor of Y. So the set 2 is a factor of 4, 2 is a
4.
factor of 6,
6.
2 is a factor of 10.
10.
3 is a factor of 6, 3 is a factor of 9. 4 is a factor of only 4. Done?
Yes,
Yes.
ma'am.
9. A cross B is given. So all the X coordinates are members of A. All the Y coordinates are members of T. So set A would be all X coordinates minus 1, 2, 3.
2, 3.
And B will be all Y coordinates.
1,
B
2.
would be
1, 2.
10. Same.
Yes, ma'am.
So in 10, it can also come as a case study where they ask us to first find A, then find B, and then find B cross A. If I directly want to find B cross, I can just swap. That also could be done. So B cross A, just swap the elements. X1 is 1x, 2y, 3x, 3y, 1y, 2x. Does it match?
Yes, ma'am.
11. A has 3 elements, A, B, and C. And that means A has cardinality 3. It's given that A cross B has cardinality 6. Therefore, the cardinality of B would be
2.
2. And now it says that there are 3 elements that are present here. A, P, B, Q, C, P. This belongs to A cross B. So all the X coordinates are members of the first set A and all the Y coordinates are members of the second set B. And we know it for a fact that A only needs to have 3 elements. So A would be A, B, C and B would be P
P,
and
comma.
Q. Any doubt?
No, ma'am.
No, ma'am.
Question number 12. Okay, some of the elements of A cross B. See, in this particular question, there's a slight problem. I won't say here that sum can be done very easily, but there is one loophole here. I have told you that some of the elements of A cross B are these. So from here you can tell me that A will have all the X coordinates. So A will have minus 1, 2 and 1. B would have 1, 3, 0. But how can I be sure that A and B will not have any more elements? They did not tell us that A and B only have 3 elements. I have given you only these opportunities, these elements, these tests from which you decipher that these are the 3 elements that are present in each of the sets. But there can be 4, 7 also. Yeah, it could have 10, 100 also. They said that some of the elements are these. But nowhere was it written. Did I miss? No, I did not miss. Nowhere was it written that A and B only has 3 elements. So technically, there could have been more elements in A and B, right? So we could not find that. But just we had to answer the question. So we have understood because they have only given us these options. That means there are only these elements. Technically, there could have been, right? Now, what else do we want? Remaining elements of A cross B. 1 second. Remaining elements are, so minus 1, 1 done, minus 1, 3, minus 1, 0. Wait, 2, 1, done. 2, 3, done. 2, 0. 1, 1, 1, 3, 1, 0 is done. Now this won't be set because they did not ask me to give the set. They only asked me to give the elements. Clear?
Yes.
So now why did we talk about Cartesian product? Cartesian product serves as a transition. So in here, if I would not have given any condition, right, that x is smaller than y or x plus y equal to 5, then we were obligated to form every single pair. We have to form the pairs, right? But if I tell about relation, what does the relation say is form as many pairs as you want, even if you don't want to don't. Relation says that if you wish to form pair, then only keep in mind that the x coordinate will be from the first set, the y coordinate will be from the second set. This already we were looking after. In A cross B also, the first set was A. So all the x coordinates were already members of A. My second set is B. The y coordinates were members of B. So I did not even violate that condition right now. So in A cross B, we say form all pairs A comma B such that A is in A first set, B is in second set. We use the word all. In relation, we don't. It says that it's a collection of pairs. It's a collection of only those elements are allowed which satisfies the condition. What's the condition? Your x coordinate should be from the first set, your y coordinate should be from the second set, right? So if I want to form a batch, the criteria is they should be having applied maths. Agree? But if I don't want to, it's okay. I haven't violated anything. I haven't written something wrong on the booklet. I may not form a batch. It's on me. What will be violating if I would have been taking core maths in this batch? That would have been violating the reason, right? So relation also says that if you want to form pairs, make sure that you don't violate the condition. What is the condition? X coordinate first set, Y coordinate second set. But if you don't want to form it, even then I'm okay. Why? Because you're sitting quiet. You're not doing anything. You're not violating anything. So I won't say that null set is not a relation. I'm okay. Why? Because it's not violating anything. Null set is a subset of every set. Why? Because it does not oppose the definition. I'm not saying it satisfies the definition. I'm saying it is not contradictory to the definition. Same goes with you. The null set can also be said as a relation. But you'll say it hasn't formed any pair. Yeah, that's why there's no contradiction. It hasn't violated anything, right? So if I take any element in relation, I can form as many pairs as I want. The only thing we need to keep in mind is the condition should not be violated, right? So now A cross B has all pairs. And in relation, I'm saying you want to write all pairs, you can. You don't want to, no. Take some pairs, even that's okay. So if in the relation I'm taking some of the pairs, it will definitely be a part of A cross because A cross B is everyone, right? Whether you're a math student or you're a non-math student, you are in CBSE affiliated, right? You're registered. Okay, no matter whether you're a math student or a non-math student, same goes here. Whether the elements are there in the relation or not, it has to be there in the Cartesian product. So Cartesian product right now serves like a universal set. Relation takes its element from that if it wants to, right? So relation can be defined in two ways. When we talk about relation, example first. Suppose set A has 1, 2 and set B has X, Y and Z. If I write A cross B full, how many elements will it have? How many elements will A cross B have?
6.
6. So 1x, 1y, 1z, 2x, 2y, 2z. There are 6 elements. Now, if I take a set R1, 1 comma x, will this be a relation according to the definition that I gave you? Will it be a relation from A to B? From A to B means the first set is A and the second set is B. Here the pair that I formed is 1 comma x. The x coordinate is 1. Does it come from the first set A?
Yes, ma'am.
The x coordinate 1 comes from the first set A. The y coordinate x comes from the second set B. So yes, it satisfies the condition of the relation. So this is a relation. Is it clear? I can also say that R1 is a subset of A cross B here. It has to be, because A cross B has taken in within every single pair that you can imagine. And what is the relation doing? It is taking some of them. So 100% every relation will be a part of A cross B. If I say R2 is null set, yes, it hasn't violated any condition. It is a relation, right? So this is a relation. And we also know it for a fact that null set is a subset of every set. So whether I say subset of A cross B or I say relation from A to B, it is same thing. If I take a subset, let us take a subset. Say 1z, 2x. This is a subset of A cross B. Yes, it is present in A cross B. Also, this is a relation. Is also a relation from A to B. It is also a relation from A to B. So whether you take subset, it will be a relation. Whether you take a relation, it will be a subset, right? So relation can be defined in two ways. A relation R from A to B denoted by R. This is the symbol, one-sided arrow, is the collection of pairs AB, where A comes from the first set and B comes from the second set. Or R is a subset of A cross B. Every relation will be a subset of A cross B. So, will it be right to say that number of relations from A to B is same as number of subsets of A cross B? Because every subset will give you a relation. Every relation is going to give you a subset. Basically, they are same, right? So the number of subset will same encounter. Every subset will give you a relation. So number of subsets will be same as the number of relation. So if A has 3 and B has 2 elements, how many elements are there in A cross B? A has 3 and B has 2 elements. How many elements are there in A cross B? 6. If a set has 6 elements, the product is having 6 elements. How many subsets will it have?
63.
64. Proper subset is 63. The
Proper
number of
subset.
subset will be 2 to the power 6, 64.
Yes.
And that is the same answer for relation also. So in MCQ, they don't ask you subset. They ask you how many relations are there. So it's equal to 2 to the power PQ. Example. If set A has 5 elements, set B has 2 elements. Number of relations from A to B would be answer
10.
10.
2 to the power 5 into 2, 10. A cross B will have 5 into 2, 10 element. So the number of subsets would be 2 to the power 10.
Yes, ma'am.
Clear?
Yes,
So
ma'am.
the process of the sums are very same. Suppose A has 1, 2, 3. B has 1, 2, 3, 4. Relation R will contain all those pairs such that y is equal to x plus 1. Find number 1, R. Answer. X will R is a relation from A to B. The first set is A. So X will take the values 1, 2, 3. If Y is there, Y will take the values 1, 2, 3, 4. So if I put X equal to 1 here, what will I get? Y2. If I take X equal to 2, I'll get Y3.
3.
If I take X equal to 3, I'll get Y4. That's it. And all of them belongs to the given sets. So 1, 2 is a pair. 2, 3 is a pair. 3, 4 is a pair. Done?
Yes, ma'am.
Everybody clear?
Ma'am.
Yes,
Now
ma'am.
comes another word, that is domain of a relation. Domain of R is set of all x coordinates in R. In R, the pairs that you have formed, just write the x coordinates. So what are the x coordinates of the elements that are there in my relation?
1, 2, 3.
1, 2, 3. Only in the pairs. There may be some extra elements in the given set. You only write from the pairs that you have formed. Similarly, there is another word, range. Range is set of all y coordinates in R. Set of all y coordinates of the pairs in R. So what are the y coordinates here?
2, 3, 4.
2, 3, 4. Yes.
Yes, ma'am.
Yes, ma'am.
Now there is another word, codomain. Codomain has no connection with R. It is directly the second set. So R was from A to B. What is my second set here? What is my second set here?
2, 3, 4.
2, 3.
Second set. I'm not saying range. I'm not saying y coordinate. I'm saying second set is what? What is my second set? B.
B.
From
B.
A to B. A is my first set, B is my second set, right? So B. Whether I have used it or not, it is a material. So codomain would be straight. If my relation is from P to Q, my codomain is Q. If my relation is from A to A, my codomain is A. No. R is a relation from A to B. So we write A as the first set, B as the second set. If I say that R is a relation on A means both the first and the second sets are in A. Are A. Both the first and the second sets are A. Both the first and second sets are A. Done?
Yes, ma'am.
Yes.
Question. My set A has 1, 2, 3 up to 14 elements. R is a relation on A. X comma Y belongs to R. Okay. 3x minus y is 0. Fine. Number 1, R. Tell me what are the pairs we can form. See, this condition means what? 3x equal to y.
Yes,
Both
ma'am.
x and y can only take values from 1 to 40. So if I put x equal to 1, y would be x is
3.
1, y is 3 into 1, 3. It's fine. If
Yes,
I
ma'am.
take x to be 2,
6.
6,
6. If I take x to be 3,
9,
9.
if I take x to be 4,
12.
12.
if I take x to be 5,
It is not possible.
because we get 15, which is out of our scope. Second, what is the domain?
1, 2, 3, 4.
All the x coordinates 1, 2, 3, 4. What is range?
3, 6, 9,
3,
4.
6, 9, 12.
What is codomain? Codomain is my second set. Yeah. A. Clear?
Yes, ma'am.
Yes, ma'am.
Any doubt?
No, ma'am.
No, ma'am.
What is a linear equation? When the variable has power 1. So every linear equation in one variable will look like what? Ax plus b equal to 0 or ax equal to b. In two variable, ax plus by equal to c. So if I say there is a linear relation, in relation there is x and y, x coordinate and y coordinate. If there is a linear relation, so y term will be there, x term would be there would be a constant term, right? So linear relation, whenever they say that there is a linear relation, we will always note linear relation. That means x and y are related by an equation, and in that the power of the variables x and y would be 1. Whenever this will happen, we'll always assume y is equal to ax plus b, where a and b can be any real numbers. You could have also written x equal to ay plus b, that doesn't matter. Now, so answer should be like y equal to 2x minus 1, y equal to 3x plus 5, y equal to x by 2 plus half, something like that. So what we want to do is we want to find a and b here. So question, we have done them in a cross b, a similar variety. Form a linear relation f 0, 5 and 4, 2 are present in it. Basically, we want to find that equation, right? Since the word linear is written, what we will assume? Let y be equal to ax plus b. This is my equation. Now, if I'm saying that 0, 5 belongs to the relation, so 0, 5 will definitely satisfy this equation. Otherwise, how am I allowed to put it in my relation? Yes or no?
Yes, ma'am.
So instead of x, we will put 0. Instead of y, we will put b. So this would be, instead of y, we will put 5. 5 equals to 0 plus b. So b would be 5. Now I'll put 4, 2. So instead of y, I have 2. Instead of x, I have 4. Now here I can put the value of b minus 3. So a would be minus 3 by 4. Any problem?
Ma'am.
No, ma'am.
That means a required relation is y equal ax plus b. Put the value here. Y would be minus 3x by 4 plus b is 5. So basically, to find the linear relation, there will only be two variables x and y because you have only two coordinates. So we'll only need to find a and b. And for that, how many equations do we need? Two variable, two equation. So how many pairs will I need? Only two. So if I give you more than two, I don't want that. You give me five, I'll use only two. I don't need more than two. Right? Yes?
Yes, ma'am.
Question. Try. Find the linear relation between the components of the ordered pairs if R is equal to 2 7 sorry 2 1 4 7 1 minus 2, so on. I can give you 5 7 8 pairs 100 pairs, doesn't matter, I'll need only two, right? So what should we start with? What should I start with?
Y is equals to ax plus b.
Now I need two pairs. Take any two pairs. Since 2
2,
1
1.
belongs to R, what will I get? The equation.
One is equal to 2a plus
1 is equal to a plus b.
So from here, B is 1 minus 2. Now 4 comma 7 also belong to R. You could have also taken 1 minus 2. Doesn't matter. 7 equal. Here I can put the value of B. B is 1 minus 2. 6 equal to A. A would be 3. Putting it in 1. B is 1 minus 2A. 1 minus 6 minus 5. So I don't want A and B. I wanted the relation actually. For required relation. Y equal ax plus. That's our answer. That is our answer. Any problem?
No, ma'am.
No, ma'am.
No, ma'am.
That's the end of our relation. So very similar Cartesian product and relation, right? Same equation in Cartesian product, they may or may not give you a condition. So in that case, you have to write every single pair. But if an equation is given, then it kind of becomes a relation, right? All the x coordinates will go into x values goes into domain. All the y values goes into range, right? Thank you.
Thank you, ma'am.